All right, everybody. Let's wrap up our basic matrix operations. We're going to talk about multiplying right now, and there's a couple of different ways we might be doing some kind of multiplication. So the first one is they might say, multiply a matrix by a non-zero constant. Okay. And again, we don't want it to be zero, right? If we multiply something by zero, that thing just goes away. It becomes a zero. So that doesn't make sense for us to do something like that. So for instance, if I had, here's my example. If I had a matrix and out in front of it, I've got a 4. It looks like I'm multiplying that through. Inside the matrix, I'm going to have the row 2, 3. And then the second row, I'm going to have -1 and 0. So if I have a number sitting outside of the matrix right there, then I can talk about distributing basically that number into the matrix. Okay, so when I see it like this means the 4 is multiplied by the entire matrix. Okay, so when I think about it, I think, well, I'm going to distribute it to the 2. I'm going to distribute it to the 3. But I'm also going to distribute it to the -1, and I'm also going to distribute it to the 0, right? So whenever I do that, what it basically means is each of those terms is going to get multiplied by that 4. So I'm not going to change the number of terms. It's just going to be 4 times 2 is 8 right here. And 4 times 3 is 12 right here. 4 times -1 is -4. 4 times 0 is 0 because anything times the 0 is a 0. So it's just kind of like distributing the 4 in, and it's not terrible, right? So let's see another example. What if it was, we're going to do a 3 by 1 matrix. So it's 10 times, and I'm going to come down 3 rows. So I've got 1.3, 0.2, and I've got 3.5. Okay, this actually ends up being more like what something you might see in the business world, because these could be dollar amounts or these could be weights or something like that. But it works out the same. I've got 3 rows and 1 column, and I'm just going to distribute that 10 into each of them. And what happens whenever I multiply something by a 10? I in my head, I hear you saying, "Move the decimal, Dr. Webster." That's what I think. So when I multiply by 10, 1.3 times 10, that turns that 1.3 into a 13, right? And when I multiply here by a 10, it moves the decimal 1 place, 10 times 0.2. Move that decimal 1 place, that's just a 2. And here, when I multiply by a 10, move that decimal place over 1, 3.5 becomes 35, right? Okay, so multiplying by 10 always, or any factor of 10, for every power of 10, it moves it 1 decimal place, right? So times 10 moves it 1 decimal place. All right, so that's the kind of stuff we're talking about here. I'm going to give you one to do on your own. I would recommend that you pause the video so you can actually work on it. I'm going to pause the video so I can work on it, and then we'll come back and push play, and we'll compare our answers. So be careful, because I'm multiplying by a -2 outside of the matrix. And my matrix is going to be a 3 by 3. So it's 3, -1, and 0 on my top row. It's -2, 1, and 3 on the middle row. And it's 0, -1, and -2 on that bottom row. Okay, so again, think about what that means. You're going to basically distribute that 2 through. And when you come back out at the other end, you should still have what will be a 3 by 3 matrix, 3 rows and 3 columns, right? Okay, so do that. I'm going to push pause. We'll come back and see if we got the same answer. Okay, so hopefully you were able to do that. I've got -6, 2, 0. I've got 4, -2, -6, And my bottom row is 0, 2, and 4. And what I would just caution you about is, of course, the same thing we always have to deal with. When you multiply anything by a 0, you get a 0, right? Here I multiply by a 0, I got a 0. And whenever you're multiplying through by a negative sign, every sign will change, right? So this was positive, it becomes a negative. This was negative, it becomes a positive because I'm multiplying by -2. So just be really careful with those negative signs and be aware that multiplying by 0 gives you a 0. All right. So where might I see something like this? Let's do a pretty straightforward example. This one's going to be on sales commissions. Okay, this is an application type problem for College of Business. And what we've got here is we're dealing with a new car agency. New car agency. All right, so here's what the word problem says. Last year's models finished in August. Next year's model starts in September. Oh, excuse me. Okay, so last year goes through August. Next year goes through September. Okay, that's what we think is going on there. It says we've got a matrix. It's already given for us, and it talks about Mr. Smith and Mr. Jones, and they have two different kinds of cars. Okay, so here's my matrix. It looks like this: Mr. Smith on the top row, Mr. Jones on the bottom row. Here's my matrix. It's going to be a 2 by 2. And on this first column, it's going to be compact cars. And on the second column, it's going to be luxury cars. And what it says is this is how much Mr. Smith sells. He sells $54,000 worth of compact cars. Okay, that's the first column. And he sells $83,000 worth of luxury cars. Okay. Mr. Jones, on the other hand, he sells $126,000 worth of compact cars, but he doesn't sell any luxury cars. Okay, that's how I would read this. Mr. Smith sold $83,000 worth of luxury cars. Like, follow them and see where they meet, right? Where does the compact and Mr. Jones meets? Right there. He sold $126,000 dollars worth. We're going to call this matrix A, and what you'll notice is whenever you're dealing with matrix stuff, a lot of times you'll use capital letters A, and this is going to be in August. Okay, so this is last year's model. All of these are last year's models for this particular thing. Okay, so there's my August stuff, and then what if well, let's go ahead and do some other stuff before I get to that one. Okay, there's my August stuff, and then they have a matrix for September. Okay, so it's the same thing. The first column is going to be compact, the second column is going to be luxury. The first row is still Mr. Smith, the second row is still Mr. Jones. Okay, and in this one, we've got $228,000 for compact for Mr. Smith, and we've got $368,000. Okay. For Jones, it's $304,000 in compacts and $322,000 in luxury. Okay. And we're going to call this B. And this is all the cars they sold in September. So that's like the new lines came out. September's the new vehicles. Okay, cool. We're making more money in September. That kind of makes sense. Okay. So there's some stuff that they asked me to do. Can you do the combined sales? So here's part A. Combined sales for August and September. So if I asked you, can you figure out the combined sales? Here's my two matrices. How much did Mr. Smith sell, for instance, in the combination of August and September? What am I asking you to do there? I'm asking you to add, right? Okay. So let's add these two together and see, okay, how much did they sell combined between the 2 months? Okay. I'm going to keep everything in the same placement. So the top row is still going to be Mr. Smith. The second row is still going to be Mr. Jones. The first column still going to be compact. The second column still going to represent luxury. And it's important that we do that because we want to make sure that when I'm adding here at this, if I go first row, first column, what does that represent? Mr. Smith's compact cars, right? This matrix, first row, first column, also Mr. Smith's compact cars. It's just another month, right? So if I'm adding those two together, okay, then what's that going to look like? A plus B, right? And I just do that one position, that one element in that one location, first row, first column is what I'm looking at. And I'm going to add those together. So let me grab a calculator. And let's see what we got. And you can put the whole 54,000 in if you want to, or if you feel good about it, you could just put the 54, right? Because they're all thousands. So you'd know that's how many dollars in sales we have, but I'm putting the whole thing. So his total sales for the 2 months is 282. 200, he's got $282,000 worth of sales in compact, right? And again, those are all in the same position. So they represent the same thing. Mr. Smith's compact. If I want his luxury, what am I going to add? His 83,000 here from August, his 368,000 here from September, and where's it going to go? Right here. First row, second column, first row, second column, first row, second column. So all of those are in the first row, second column position, right? Okay. That's what we're talking about. So if I want to add those, let me do that. Clear. I'm going to cheat this time. 368 plus 83. And I know that these are both in the thousands, right? Okay, so $451,000 worth of sales. Okay, so I say you guys go ahead and pause and see if you can get the other two that numbers. So this one, second row, first column down here, that's going to be Mr. Jones's compacts, right? How much does he have? And then second row, second column, this is Mr. Jones's total luxury vehicles. I can do that one. Oh, excuse me. I can do that one really quickly because he had a 0 in the first month, right? So that's 322,000. But it's going to take me a second. I need to probably use my calculator or do some math. 304 plus 126, right? $430,000 worth of sales combined for the months of August and September for Mr. Jones when we're talking about compact cars. Okay, so that's kind of the way I'm going to do this. That's part A. We're going to figure out what he's got going on for part B, but that's the idea here. So let's see. Part B says, what are the, how much did sales increase from August to September? Okay. How much, I'm sorry. Excuse me. How much did sales increase from August to September? Okay, so we said on the last one we wanted the total. That was add. So actually that was matrix A plus matrix B, and we would write it like A plus B. Okay, but now we want to know how much they decreased. Now I want what? The difference between the two mass or months. So I want B minus A. I want the difference there. So I'm going to have to do a different kind of operation, right? That's going to be subtraction, not addition. So that's going to be September minus August. Well, let's see. September was, let me rewrite this matrix here. So what we're saying is to do B minus A, we're doing September was 228, 368, so 228 and 368, and then we had 304 and 322. thousand on each of those. Okay. And I'm dropping the labels, but we all know Smith is the first row, Jones is the second row, compact is the first column, luxury is the second column. And the August matrix, so I'm going to minus because I'm looking for the difference between them. I want to know how much it increased. 54,000, 83,000, 126,000, and 0. And honestly, all these sales numbers and things like that, that's probably in a spreadsheet somewhere. So we can probably grab some columns and some rows and figure it out. Easier to do the math that way. Like you can do this on an Excel spreadsheet or something like that using columns and rows, just like we're using in the matrix here. So those sales records are going to be somewhere in your back office, right? That's not something that I'm going to figure out right now. Okay, but I'm going to subtract these. It's going to tell me the difference, and not just the difference, but the difference for each one of them, right? So for this one, this was Mr. Smith, and this is Mr. Jones. And if I want to compare Mr. Smith's, how much he increased between 228 and 500, or I'm sorry, 228 and 54, 228,000 minus 54,000, 174,000 is the difference, right? Okay. And then that was Mr. Smith's compact cells. They increased by 174,000. Okay. What about this one? And I'm going to drop the thousands again. 368 minus 83. Those are all in thousands. $285,000 more in sales on luxury cars. So Mr. Smith really increased. He did really well there, right? What about Mr. Jones? It's 304,000 minus 126,000, $178,000 more in compact cars. And we can do this subtraction really easy. 322 minus 0, because remember, it's always position specific, right? So this is Mr. Jones's luxury cars. This is Mr. Jones's luxury cars. I'm subtracting those two elements, and that's what I put in that same spot right there, that same position. So he actually had a really great increase on the luxury cars because he didn't sell any in August, right? But in September with a new model, he's like on it for sales. So that's good. Good for Mr. Jones there, right? We put Smith first, Jones second. All right, so that's part B. Part C said, what if each of these make a 5% commission in September on all the cars they sell? What if they each make a 5% commission? Okay, so what am I asking you to figure out? I want to know how much their commission is. So find the commission. That's what I'm asking for. Okay, what am I asking you to do? Take 5% of September. September was the second matrix. I've got it right there. Okay, take 5% of September. That's the B guy. 5% of B is what I'm asking you to figure out, okay? But we know 5% is the same as what? 0.05 times the B? Hey, that's just multiplying a whole number, or not a whole number, multiplying a constant out in front, right? So what's that going to look like? All right, I'm going to have 5% or 0.05. It's going to be out in the front. I'm going to pick the September matrix, which was 228,000 and 368,000. And then down here is 304,000 and 322,000, right? That was the September matrix, just writing it down again. But to find out what their commission is on each of them or on all of them, I'm going to have to multiply by 0.05, right? So 228 times 0.05. That's $11,400. So for this one right here, Mr. Smith, just on the compact vehicles, at 5% of his sales, he's making for this 1 month $11,400 just in commissions. Okay. What about 368,000 times 0.05? I'm putting the full thousands just so you'll believe me on the decimal points. 18,400. If you're good with moving those decimal points without having to have the calculator work it all out for you, that's great. Okay. That's a lot of commissions on those luxuries. Okay. So if that's his total commissions for that, just the 1 month, that's great. The problem with working on commissions is you could have one really great month and then 11 really bad months. So 15,200 for this one, right? I'm just distributing this 0.05. It's got to be multiplied by everything, right? So this guy here is 15,200. And last but not least, 322,000 times 0.05. 16,100. Okay. So that's what we've got. Those are their commissions. They're making great money. If they could do that every single money, they'd be doing really well. They're probably not doing that every single month, but that's what they had for September. Okay. So this is an example of what it looks like for you to do. An application type problem using the matrices. We've done adding matrices, we've done subtracting matrices, we've done multiplying by a constant. Okay. All of those, you could see that kind of stuff going on very easily inside of a College of Business application. All right. So that is just kind of normal stuff, getting it in there. Okay. Now, if you'd like a problem to work on for yourself, I'm just going to give you a problem. I'm not going to do it. But what if you can work on it and see what you get? What if matrix A was 45,000, 77,000, and then the second row 106,000 and 22,000. And matrix B, so that was August, remember? Same problem, we're just changing the numbers. B is 190,000 and 345,000. And the second row is 266,000 and 276,000. Okay, so this is just for you to practice if you want to. You've got these two matrices. You can do the same thing. So part A would be A plus B, find the sum, their total. Part B would be B minus A, find the difference. Part C would be figure out the commission, right, for the second month. You don't have to do the second month. You could do the first month. You can do however you want to there. But that was the same problem that we just worked. So if you'd like some practice, you'd like to play with it, go ahead and do that one. I'm not going to work that problem. If you really want answers, you could email me or something and I could help you. But that's just a problem for you to use if you need help. Okay. So we've covered multiplying matrices by just a constant, but there's also something called matrix products. Matrix products is when I multiply two matrices together. Okay, and this is a little more complicated. It's not as easy as just distributing that one guy through, but that's the idea behind matrix products, two matrices that we're going to multiply together. Okay, so the idea here is we're going to have to, before we can do anything, okay, with this, we have to figure out their sizes, the matrix sizes. So I'm going to give you kind of a little definition here for when we can do this and when we can't. But sometimes in the definition we get lost a little bit. So I'll come back and explain it. Okay. The definition for this says if A is an N by P matrix, And B is a P by M matrix. So one's an N, one's an M matrix. Then the matrix product, that's what we're looking for here. Matrix product will be an N by M matrix. Okay. So it's that N by M matrix. Okay, so what that's going to look like is it's going to look like I'm going A times B. I'm multiplying those two together, A times B, and I'm going to get a matrix. Okay, we're going to have to do it in special ways. And before I can do anything with this, notice that the thing we have to be able to do here is the number of columns in the first matrix. It doesn't have to be A, it could be whatever matrix. And the number of rows in the second matrix, those are both P. Those numbers match. So what we're going to do is when we go to do this, we're going to write it down side by side. Okay, I think it helps if you do this. You've got the A times the B, and you're going to say, hey, my A is N times P. Okay, and I'm going to multiply that. So times, it's going to be a P times M. And I'm doing all of this before I can even do the multiplication. I write them down side by side, and I say, do the numbers on the inside closest to each other match? Okay. The number of columns from this first one matches the number of rows in the second one. If it does, those are the same number, then yes, I can multiply these. And yes, I will get an N by M matrix. That will be my solution. Okay. So A times B is going to be N times M. That's its dimensions. Okay. We haven't done anything about how you multiply yet. Before you even start thinking about it, we have to check. Okay, so the first thing we're going to do is we're going to check. Okay, so now we've checked. And now what we do is in order to multiply, you multiply row number 1 in A, okay, the first row in the first one, times column number 1 in B. I'll show you what this looks like. Don't stress out. Okay. And whatever that answer is, that answer goes into the position 1, 1. Now, remember, I talked about this before. Whenever I talk about positions inside of a matrix, this is the row and this is the column. So this is row 1, column 1. And look, that matches with what I pulled. I pulled row 1 from A, row 1, and I pulled column 1 from B. That's column 1. Okay, that's the position that's going to take up, and so on and so on and so on. So, etc. Okay, we'll see how that looks in just a second. Okay, so if the number of columns in A and the number of rows in B is not the same, if you don't have the same P, same sized P's, then you can't multiply. Okay, so let's wrap that up so we know, hey, if this doesn't match, if these two aren't the same number, then you can't multiply, and you will say something like the matrix product is not defined, or no solution, or we can't do it. This is where you can use that circle with a slash through it. Some of you like to use for a 0. That actually means no solution, so don't use that as a 0. All right, so that's what we're going to do. And you're thinking, well, how in the world am I going to do this? Let's get an example. It's not as bad as it sounds. And in fact, once you start doing it, it has kind of a rhythm to it, like how you're going to do this over and over again. It's not going to be bad. Okay, but let's see. Let's say we have, here's my example. A equals, my matrix is going to be 2, 3, -1 on the top row, and -2, 1, 2 on the second row. Okay. And my other matrix is going to be B, and that's going to be 3 rows deep. So it's going to be a 1 and a 3 on the top row, a 2 and a 0 in the middle, and a -1 and a 2 on the bottom. Okay. So those are my two matrices. And again, before we do anything, we need to determine their size. And remember, it's always row times column. Okay. So how many rows does this first one have? The A has a 1, 2 rows, right? So it's 2 times how many columns? 1, 2, 3. It's a 2 by 3 matrix, right? So that's what we're multiplying here. And what about over here? How many rows? 1, 2, 3 rows by how many columns? 2 columns, right? Okay. So this is my first one. This is my second one. The numbers that are closer to each other, those two, do they match? That's what I want to know. Are those the same? Yes, those are the same. So the number of columns in A is the same as the number of rows in B. Okay. So what that tells us, we say yes, they match. We can multiply. So you have to do that check before you even do anything else. Don't start multiplying. Don't just jump in there. You have to check. Okay. So now, how big is my solution matrix going to be? The product. What did we say? Go find your N, go find your M. And so my product is going to be a 2 by 2, right? This guy by that guy. That's what we're going to have there. And some people kind of freak out. Wait, I started with a 2 by 3 and a 3 by 2, and I'm going to end up with a smaller matrix. And the answer is yeah, you're going to end up with a smaller matrix, and that's okay. All right, it's okay. So how do we do this? All right, let me show you. What we're going to do, we want this very first position, and I'm going to put AB right here. AB equals, for sure, I think I can fit him. It's going to be a 2 by 2. We know that. Maybe I shouldn't put that bracket yet. Sorry. Okay. We're going to take this row here, row number 1 in matrix A. We're going to multiply it by column number 1 in matrix B. And the trick here is, how do I add, or how do I multiply? Yeah, I didn't need that bracket there. I'm sorry. Okay. The way I multiply is element by element. The first guy times the first guy. Well, that's a 2. Plus the second guy times the second guy. 3 times 2 is a 6. Plus the third guy times the third guy. -1 times a -1 is a 1. And all of that goes in the first row, first column. So it's in that first position. Okay. Then what? So you get a feel for it once you start multiplying and adding. It's okay. First row times second column, right? First row times second column. Where's the answer for this? First row times second column going to be? It's going to be in the first row, second column. It's going to be right here. And I'll show my math right there. So I'll have space. Okay. So let's do it element by element. 2 times 3 is 6. 3 times 0 is 0. -1 times 2 is -2, right? We'll come back and simplify this in a minute. Okay, let's go down a little bit. Second row, let me grab this with like a green or something. Second row times the first column. That's what I'm looking at here. Okay, second row, first column. Where does that go? Second row, first column. My answer is going to go right here, right? All right, let's see it. Second row, first column. -2 times 1. -2. 1 times 2. What's that? 2. So it's multiply, add, multiply, add, multiply, add. So I'm going to go plus 2 times 1. I'm sorry, that's a -1. I've marked over it. I apologize. 2 times -1 is a -2. Okay. And then one more, the very last one. Second row, second column. That's going to go in this position. Second row, second column. And you do it. Okay. Multiply, add, and you go position by position. Negative 2 times 3, negative 6. 1 times 0 is a 0. 2 times 2, that's a 4. All right. So that's what we're doing here. And all we got to do now is once we've done row times column, we multiply, add. Now I just got to clean this up, right? So AB is going to equal, well, what is that first spot? Okay, row 1, column 1. 2 plus 6 is 8, plus 1 is 9. 6 plus 0 is 6, minus 2, so it's plus and minus 2 is 4. Okay. Negative 2 plus 2, that's a 0. Plus a negative 2, that's a negative 2. Negative 6 plus 0, that's just negative 6. Plus 4 is negative 2. There we go. We got our product. Okay. So that's the process for that. It is a little bit more complicated than just multiplying by a constant. You are going to have to work through some of these and get that feel for that pattern before you just go, oh, I know how to multiply these matrices, but they're doable. You can do it. I promise. I've had other students do it. It's definitely doable. Okay. So here we go. Here's again, unusual maybe looking problem. This guy. We've got two matrices. It's 2, negative 3, and 0. So what's this guy's size? 1 by 3. 1 row, 3 columns, right? And then the other matrix is going to be a vertical guy. Negative 5, 2, negative 2. What's that guy's size? 3 by 1. Absolutely. Okay. So that's where we are on that. Okay. Let's look at the dimensions and see, can I multiply these? This is a 3 on the columns. This is a 3 on the row. Do those match? Yes, indeed they do. How big is this going to be when I'm finished? So AB is going to be, A times B is going to be a 1 by 1. Okay. Well, 1 by 1 is just 1, right? Okay. So let's see what that looks like. Okay. I'm going to do the first row times the first column. Oh, that's what's up. There's only 1 row and 1 column. So there's only the first row, first column position, right? Okay. So let's see it. Multiply the first two together. Negative 10. Plus. Multiply the second two together. Negative 6. Plus. Multiply the last two together. Well, hey, 0 times any number is 0. So what do I have? Negative 10, negative 6, 0. This looks like a negative 16 to me. And indeed, that is a 1 by 1 matrix. It's got 1 row and 1 column. All right, that's cool. We can do that. Is that all right? Everybody's good. All right. Try this one on your own. I'll push pause in a second and work it out. You see how you do. The example is negative 1, 0, 3, 2. And there's another vertical guy. 2, 3, 4, negative 1. So the first thing you need to do is figure out how big each of these are, decide if you can multiply them, and then if you can, go ahead and do the multiplication. So I'm going to push pause, you push pause, we'll see what we get. All right, this is what I think I've got. I've got a 1 by 4 and I've got a 4 by 1, and sure enough, those dimensions match. The columns here and the rows are the same. So that means I can multiply these, and it means that my AB guy is going to be a 1 by 1. Okay. And I've kind of got my green lines drawn here. Distribute the negative 1 times the 2. I get a negative 2. Plus 0 times the 3. I get a 0. Plus 3 times the 4. I get a 12. Plus 2 times negative 1. I get a negative 2. That's all going to go in the first row, first column position, right? Because I've got 1 row, 1 column. And I had this 1 by 4. I had this 4 by 1. They were kind of long, but I end up with a 1 by 1, and it's just an 8. So sure enough, we can do that. All right. We can do it, and we did do it, and we got an answer. That's awesome when we do that. Okay. All right. Let's do just a couple of more examples and see where we're standing. What they do in your book. Yeah. What they do in your book is they just kind of start saying, what if A is this? What if B is that? What if C is that? What if D is that? So let me give you 4 different matrices and we'll see. Okay. So A equals, it's a 2, -1, 1, 0, -1, 2. Okay. What size is that? 3 rows and 2 columns. Okay. And then B is going to be 1, -1, 0, 1, 2, 1, 2, 0. So how big is that? That's a 2 by 4, right? Okay. Oh, sorry. Let me scoot that up. I apologize. So that gives me 2 matrices, and we're going to go ahead. C is 2 and 6 on the first row, and -1 and -3 on the second row. So this is a 2 by 2. And last but not least, we've got D, 1 and 2 on the first row. And then on the second row, we've got 3 and 6. And that is also what? 2 by 2, right? Okay, so I give you 4 matrices. You're looking at all of them. You're thinking, what are the different sizes? You're figuring that out, right? And then they're just going to ask me some stuff like, can you do this? Okay, so can you do this? Can you do A times B? And if you can, then do it. A times B. All right, let's think about it. Well, what do I have here for the dimensions? I've got a 3 by 2, and I'm multiplying that by a 2 by 4. Okay, do the inside guys match? Yep, they do. Okay, so I can multiply these, and my question is, how big is that new matrix going to be? It's going to be a what? 3 rows and 4 columns. So actually, with this one, it looks like my matrices are going to get bigger when I multiply them, more dimensions, right? A bigger size, not necessarily numbers. Okay, so hey, that's going to become a 3 by 4. Okay, so let's do it real quickly and see what we got. So I'm going to say, I'm just going to start it. I'm kind of running out of space here. I write big. I'm sorry. Okay. Actually, let me scoot it out maybe. Sorry about that. Sorry, my finger's on it. Okay, I'm scooting it out just a little bit. Maybe we can see a little bit more. Okay, so how do I do A times B? I'm going to do first row times first column, right? Okay, well, we can do that. 2 times 1, that's a 2, plus -1 times 2, that's a -2. Okay, that goes in the first row, first column. I'm good. Let's keep going. First row, second column. 2 times -1, well, that's a -2. -1 times 1, that's a -1. Okay, that goes in the first row, second column. I'm good there. First row times third column. Okay, this is where it starts getting interesting. 2 times 0, that's a 0. -1 times 2, that's a -2. Okay. And here's where we expand our matrix, so to speak. It gets bigger. 2 times 1, because I got to do first row times fourth column, right? So I'm going to have something in the first row, fourth column position right here. Okay, that's how it gets bigger. So 2 times 1, that's a 2. -1 times 0, that's a +0. Okay. So we need to do this for the next two rows of A. So I need to go, next I will go row 2 times column 1 times column 2 times column 3. And that will go in the row 2 position. So go ahead, push pause. I'm going to push pause, see what you do, see what you get, and we'll compare. All right, so I have multiplied mine out. Let me scoot. I'll come back if I need the A, B, C, D in a minute. Okay. So I've multiplied mine out. And what I found was this is what I've done. I haven't simplified it yet, but watch out whenever you do the second row times the third column. So it's second row times the third column. First times first, that's a 0. Second times second, that's a 0. So I've got 0 plus 0 here, right? Okay, so I've got 0 plus 0 there. What is that? That's a 0, right? So just be a little bit careful because sometimes things like that happen. We're going to get a 0. Okay, let's see what we got. Okay, 2 plus negative 2, that's a 0. Negative 2 minus 1, that's a negative 3. 0 minus 2, that's a negative 2. 2 plus 0, that's a 2. Okay, 1 plus 0, 1. Negative 1 plus 0, negative 1. 0 plus 0, 0. Negative 1 plus 0, negative 1. Now we got a lot of zeros on that one because the second element in this second row was a 0, right? So that's where all those zeros came from. So no biggie. It's all right. We didn't mess anything up. Negative 1 plus 4, that's a 3. 1 plus 3, that's a 4. 0 plus 4, that's a 4. Negative 1 plus 0, that's a negative 1. Okay, look at that and tell me how big that guy is now that we've worked all the way through this. He's what? 3 rows by 1, 2, 3, 4 columns. Sure enough, he really is 3 rows by 4 columns. So I started out with a 3 by 2 and a 2 by 4, but then whenever I started doing the math, the matrix kind of got bigger. It expanded, bigger dimensions. And there we go. Isn't that interesting? That's just so crazy. All right. So we got AB. No big deal. Okay. I'm sorry. Hang on just a second. That's not what I have in my notes. So let me look. I'm sorry. Sorry. My notes were a different problem. Okay, we're good. I think we're good. All right. If you got a different answer than that, just let me know. Sorry. Okay, so what if it said, we just did A times B, right? Example A times B. What if it said, well, now go back and do B times A? Okay. Because in multiplication of like regular numbers, we can do, if we can do A by B, A times B, right? We can do B times A because we have this principle that says order doesn't matter whenever I'm multiplying. So what about that? Well, what's B? If you'll remember, it was a 2 by 4. And we're multiplying that times A. And if you remember his dimensions, that's 3 by 2. So again, before you get all gung-ho and start doing this math, just jump into doing the multiplication. Check. Because what do we think about those? Do those match? 4 columns and 3 rows? The answer is no. So can I multiply these? The answer is no. You cannot multiply. Don't even try it. So you can say something like no solution or not defined. I think your book likes not defined. It's probably what you'll see a lot in the my math lab homework, that kind of thing. But that's what you're looking at. We can't do it because the dimensions, the innermost numbers, the columns here, the rows here are not the same. We can only do this interesting multiply add thing only works whenever those numbers match. Okay. So what about, how about, and this is another example, CD, C times D. Okay, well, C is a 2 by 2 and D is a 2 by 2. Check those inside dimensions, columns out of C, rows out of D. Do those match? Yes. Okay, so now we can multiply those, right? So let's see what that looks like. What we're doing, CD is going to look like, let me just rewrite them because it's on a different page. It's 2, 6, negative 1, negative 3, and 1, 2, 3, 6. There's my C, and there's my D. Okay, those two matrices. C times D. Okay, well, let's just get to work and do it. You can do it. So By the way, what's the dimensions of my new one going to be? My product's going to be a 2 by 2, right? So this is actually going to end up being the same size whenever I finish it. Okay, so first row times first column. I find it helps me if I both circle the row in the column I'm working on and put my finger on it. Okay, so both of those things help me. 2 times 1 is 2 plus 3 times 6 is 18. Okay. First row times second column. 2 times 2 is 4 plus 6 times 6 is 36. Be careful because we're multiplying element times element, first times first, plus we're multiplying second times second. So this is a 36. I've seen people put 12 there before, so just watch out. Okay, then for this second row, first column, 1 times -1 is -1 plus -3 times 3 is a -9. Second row, second column. It's going to go in the second row, second column position. -1 times 2, that's a -2. Plus -3 times +16 is a -18. All right. So before we go any further, do I have a 2 by 2? I will whenever I clean this up, right? Sure enough, we do. All right. So there you go. All right. What about that? 2 and 18 is 20. 4 and 36 is 40. -1 and -9 is -10. -2 and -18 is -20. There's my C times D. All right. Okay, well, that's cool. Then we want to know stuff like, well, can I do other stuff? In regular multiplication, if I did C times D and I got this thing, then when I do D times C, I also get that thing. But we don't know if that's the way it is with matrices, so let's check. Okay. The nice thing about C and D is they are what we call a square matrix, right? 2 by 2. So the dimensions are the same. Okay. So the cool thing is whenever I say, can we do D times C? Well, it's still a 2 by 2 times a 2 by 2, right? So those two inside numbers still match. So yes, we can multiply it. So that's the first check. Yes, I can multiply it. But the question is, when I switch the order of these two matrices, do I get the same thing? That's the question. So let's check it and see. I don't know. Let's see. So if I switch them, then it's 1, 2, 3, 6. That's my D guy. And then it's 2, 6, -1, -3. That's my C guy. And I'm going to multiply those. And I know I should be getting, whenever I'm all said and done, I should be getting a 2 by 2, right? 2 by 2. That's the dimensions that are left over. I like to think it's the rows from the first one and the columns from the second one. So it literally tells me 2 by 2 is my answer. If I got rid of the middle guys, that's what's left over. Okay. First row, first column. 1 times 2 is 2 plus 2 times -2. I'm sorry, 2 times -1 is -2. Okay. Well, I can already tell you this isn't going to be the same thing because 2 plus -2 is what? 0. And we had a 20 in that position last time. So they're not going to be the same thing. That's interesting. First row, second column. 1 times 6 is a 6 plus 1 times 6 is 6. 2 times -3 is a -6. Okay, that's also going to be 0. 3 times 2 is a 6 plus 6 times -1 is a -6. That's also a 0. And then the last one is going to be second row, second column. He's going to go right here. 3 times 6 is an 18 plus 6 times -3 is a -18. This guy is completely 0, 0, 0, 0. Now, that's not an empty matrix. I actually have answers 0, 0, 0, 0. If this was Mr. Smith's compact car sales for this month, that would be a 0, right? So we still have numbers in there that is a matrix, but that's an interesting thing that they all zeroed out. They all zeroed out because basically we have flip-flops of each number here, right? Whenever we look at it. whenever we did it the other direction, the combinations didn't cancel out the way these do. Okay. These just reduced right out. So, and sure enough, it's a 2 by 2, right? So we are good. So we can do DC because these inner dimensions match. It's just that it's not going to be the same as CD. So you can't just say, oh, I just did C times D. Now it's asking me to do D times C. It's going to be the same thing. That's not true. That happens when we're dealing with our normal multiplication. 2 times 5 is the same as 5 times 2, but it's not going to happen with matrices. So you can't do that. Okay. I'm going to ask you a couple. I just want you to say, can I do it? Can I not do it? If you would like to then turn around and do these questions on your own, sure, go ahead, do that. But I don't think we need to. It'll be, I mean, I feel like we've done enough of these examples that you can probably work on your homework. But if you're like, hey, I really want to do something, then go for it. It'll be fun. Okay, so my next example is, can I do A times A? So you can multiply it and see for real if you wanted to, but I just want to know, can I? Is it even possible to do that multiplication? So remember, A was a 3 by 2. So if I do that, I've got a 3 by 2, 3 by 2 times itself would be times a 3 by 2. What do you think? Close my parentheses. Look at those inside dimensions. Are the columns here the same as the rows here? I say no. They don't match. We can't multiply them. Okay. How about if I asked you to do B times B? Can you do that? Let's see. 2 times 4 for the B. So it would be a 2 times 4 times itself, a 2 times 4. Do those match? Look at those inner dimensions. Nope, they still don't match. Nope, not going to do it. Okay. What about A times C? Okay, let's see. A is a 3 by 2. And C was a 2 by 2. Can I do that one? Oh, yeah, those two in the middle do match. Yes, we can do this multiplication if you want to. I'm not going to do it. If you want to do it, go multiply matrix A. We have it, matrix A times matrix C, and you can get there. Which also means, by the way, I could do matrix A times matrix D if I wanted to, right? Can I do it the other way around? Can I do C times A? Oh, let's see. C times A. Think about it. What do you think? You think you can do that? No. Okay. So those don't match. We can't do that. So here it's possible for me to do A times C, but it is not possible for me to do C times A. And that's interesting because earlier I could do CD and I could do DC, but remember those were square. What do we think about A? He's 3 by 2. So we can't do him. Okay. Like we can't just interchange it. It's not a square matrix like this guy was. Okay. So you could also do the similar thing with A times D. Can we do that? A is 3 by 2. D is 2 by 2. Can you multiply them? Yeah, I can do that. Absolutely, that works. So if you want to try that problem on your own, you absolutely can. But if we swap these and try to do D times A, that would be a 2 by 2 times a 3 by 2. And look at those interior numbers. No. All right. So that's what's going on here. The first big thing, like I told you, you have got to work this out and see what you're going to get whenever you've got to check them first. I'm sorry, that's what I was going to say. You've got to check them first before you just start working them out, because you're going to see whether it's even worth my time to try it. Because if you try it and the dimensions don't match, on those insides, then you're not going to be able to multiply. You're going to start multiplying and you're going to have like one extra row or one extra column that's not going to it's not going to match up and you're not going to be able to do it. Okay. That's it for the multiplying of the matrices. So you've got two things you can do when you're multiplying. You can either multiply by a constant out in front, like we did earlier, right? 0.05 times C, okay? And in that case, you distribute that 0.05 through every single element inside of the matrix. Or we can do, okay, so this is a matrix times a constant. We can absolutely do that. Or we can do something like C times D, and that's going to be called a matrix product. Okay, so two different pieces there. We're very capable of doing both of them. It's not difficult, but they are two different processes. So make sure when you're looking at that, you know the difference. All right. Okay, that's it for multiplication. Let me know if you have questions. Have a great day.